In this video, we're going to talk about the strategy of cross-canceling. The purpose of this strategy is that so we don't have to multiply it all out and then get to the end and then have to reduce or simplify our product. This way we reduce and simplify it before so that when we actually come to a product, it's as simplified as it can be. So I have a mixed number times a fraction. If that's the case, I'm going to first change the mixed number to an improper fraction. So 3 1/5 will become 5 times 3 is 15, plus 1 is 16. And my denominator stays the same, so 16 fifths times 19 eighths. All right, so before I do the standard algorithm of numerator times numerator and denominator times denominator, I'm going to cross cancel if I can so that I don't have to do it at the end. So I need to first find the greatest common factor between 16 and 8. So cross canceling, you always go diagonal. So I have 16 and 8. So I'm going to find all the factors of 16. So I have 1 and 16. I have 2 and 8. I have 4 and 4. All right. And now I'm going to do 8. And with 8, I have 1 times 8, 2 times 4. And that is it. So now that I have found that, my greatest common factor between 16 and 8 is going to be 8. So I'm going to take my greatest common factor and divide it by these numbers. So 8 divided by 8 is 1. 16 divided by 8 is 2. So I've just already simplified those numbers. Now I'm going to see if I have any common factors between 5 and 19. So I'm going to do the same thing. 1 and 5 and 19, 1 and 19. Now I do have the common factor of 1. However, whenever my greatest common factor is 1, this stays the same because 5 divided by 1 is 5, 19 divided by 1 is 19. So those don't change their value. Now I am going to do it the traditional way, and I'm going to multiply across and get 38 from 2 times 19, and then 5 times 5 times 1 is going to be 5. And now I'm going to make 38 fifths into an improper, or into a mixed number by dividing out if I need to, or I can do it in my head. This would be 35, subtract 2. I'm going to go around the world, and 7 is my whole number with 2 as my numerator and 5 as my denominator. So my product, or my answer, is 7 2/5. Now, had I not done the cross-canceling strategy, I would have had to multiply 16 times 19 and then 5 times 8, gotten that as an improper fraction, made it into a mixed number, and then had to simplify this. So by doing this on the forefront, it eliminates me having to worry about changing the answer that I get at the end. So that is one example of using the strategy of cross-canceling. We're going to do one more. We are going to do 7/10 times 2/5. Okay, and it is going to be the same thing. So in this example, I have two fractions, so nothing has to be changed, and I'm going to look diagonally. I know that the only factors of 7 are 1 and 7. The only factors of 5 are 1 and 5. So the greatest common factor is 1. Now remember, when that happens, the value of these numbers don't change, so that can stay the same. And then I'm going to look at 2 and 10. This is 1 and 2. This is 1, 10, 2, and 5. This is where it comes in handy really knowing your multiplication facts, because then you can spew these out. All right, so then my greatest common factor between 2 and 10 is going to be 2. So 5, we're looking here. 2 divided by 2 is 1. 10 divided by 2 is 5. And I multiply across. 7 times 1 is 7. 5 times 5 is 25. And 7 25ths is my answer, and that cannot be reduced any further. If you get to your product and you're not sure if you had chosen your greatest common factor, maybe you missed some factors and you're wondering if you did it right because you don't know if this can be further reduced, well then go ahead and find the factors of both of the numbers of your numerator and denominator in your answer, and you know that you have simplified it as much as you can when your greatest common factor between your numerator and denominator is 1, because that means that these cannot be simplified any longer or any further. All right, so that is the strategy of cross-canceling. You simply go diagonal and diagonal, find the greatest common factor of the pairs, so in this case 7 and 5. The greatest common factor You divide it by each of these numbers if it's not 1. So here, between 10 and 2 is 2. We divided 10 into 2, 2 into 2. And then we simplified and we multiplied straight across using the standard algorithm.